Hello intellectuals, I'm Mr. Davis. Today, I am back with another chemistry video.
Wow!
But this time, it's about the comparison of calcium and the first row of transition metal elements. Just a quick disclaimer. Although the modern IUPAC definition considers scandium and zinc to be part of a transition metal, the CIE syllabus, for some reason, does not think that scandium and zinc are transition metals. But for the accuracy of this video, I will consider scandium and zinc as a transition metal because beep. So as we learned from IGCSE, metals undergo metallic bonding, and one of the properties that follows along that is high melting point. But transition metals in specific seems to have higher melting points than normal metals. Well, this is because the strength of the bond is related to the number of electrons delocalized. So calcium, for example, forms a 2+ ion. That means only 2 electrons are delocalized per cation. Also, this only involves the 4s2 orbital. However, for scandium and the other transition metals, their 3d orbitals are involved as well. And also metals often have more than one oxidation states, meaning they lose more than 2 electrons. So if they lose more electrons, that means they have a stronger cation charge. A stronger cation charge would result in stronger attractive forces that's holding the metal solid together.
Yeah, this makes the bond stronger because more electrons.
Beep. With atomic radii, there is a general decrease across the period. Well, this is because as the proton number increases, the atoms are still experiencing relatively the same amount of shielding because the 4s and the 3d orbitals are in similar energy levels. So there is an increase of attractive forces at the valence electrons, making the electron clouds collapse in a bit. Beep! We've learned that the atomic radii decreases from calcium to zinc. However, the proton number increases. Besides the increase in charge, there's also an increase in mass. This means that we can fit a lot more transition metal elements in the same space than calcium. Hence, through this, we can also conclude that transition metals are generally more dense than calcium. Bloop! Well, this also means that the ionic radii decreases across the period, excluding nonmetals because they gain electrons. As the metals lose their valence electrons, they would all be left with the same electron configuration. However, the magnitude of positive charge is higher, or there's an increased attraction of the nucleus and the outer shell electrons. Beep. So, moving on to ionization energy. If there's the same shielding, but then the protons increases, that means there's an increased attractive force on the valence electrons. That means you would need more energy to overcome that attractive force to remove the first electron. The general ionization energy trend for calcium and to scandium will be shown here. There are some exceptions to the general trend because of electron spin pair repulsion. Beep! Why am I doing this? Well, besides the reason being is for extra credit, we are also trying to learn how to appreciate the d orbitals and how it would affect physical properties by comparing it to the element
Before it appears calcium.
Bye.